Hello, you guys. I hope everyone had a wonderful weekend. We are starting a brand new unit today, and also it's your last unit. So I know you guys are excited about finishing these math classes and moving on, and you will be so glad you stayed the course. All right, so the first thing I want to talk to you about is the final exploration project. We have talked about it before, but we're going to share those toward the end of April. And so I just wanted to remind you what is required for your final exploration project. You are going to present a one-page double-spaced type paper with 1-inch margins. It should include at a minimum the answers to the following questions. What is your program? Why did you choose this program? How do you use math in your program? Give 2 or more examples. How has this class helped you prepare for your future? Where do you see yourself in 5 years and 10 years from now? You should also interview someone in your program and include these findings in the paper. Now remember, it's just a one-page typed papers, and once you've answered all these questions, really, I mean, it's not as scary as it might appear to be immediately, because once you answer all those questions, that's going to about fill a page. So just giving someone else's perspective on, you know, what they've done in your particular field is going to not only give you some insight, but I think it's good information for you guys all to know. You're going to present your paper. I'm going to start letting you sign up for those spots probably next week. We'll talk about specific times where you guys can share your papers. Okay. Obviously, posters isn't appropriate, or it doesn't make any sense for virtual classrooms, but of course you can prepare any kind of visual. You can share a PowerPoint presentation with us or anything else if you choose to, but that's optional. And I am sending you not only the paper, the slide I just read, but also the rubric, the way you will be graded on this assignment as well. So you will have this information in front of you. All right, so just a reminder, you guys need to be working on that. All right, so you guys are going to be doing 3 sections for Monday and also Tuesday night's class. So 7R1, 7R2, and 7R3. So the objectives for 7R1 are, we're going to use the product rule for exponents. We're going to simplify expressions that contain the exponent 0. We're going to use the quotient rule for exponents. We're going to simplify expressions that contain negative exponents. And we're going to use our calculators to help us out a little bit. So make sure you take a look at your guided notebook, page 97, for properties and definitions. All right, so basically our first rule for exponents is when we have 2 numbers that have the same base. So of course a base is whatever is being raised to a specific power. So on letter A, our one base is x. Both of these terms is raised to a power. The first one is the power of 2. The second one is the power of 4. So the rule is when you have 2 numbers that have the same base that are being multiplied, the rule is to add those exponents. We're going to add 2 plus 4 because our bases are the same, and 2 plus 4 is 6. Okay. All right, now letter B, we do have A raised to the first power, so A is still considered a base. B is a base, but since these bases are not equal, they're not the same base, that means we can still multiply A times B and we get AB to the 6th power. So technically only the B is raised to the 6th power. So if the bases are the same, you just stick those variables together and that shows multiplication. Now, if you notice on letter A, we just included the base as our answer and we added those exponents. So here we have the base of which is 4. So we have 4 raised to the 2nd power, 4 raised to the 1st power. Since the bases are the same, we're not multiplying 4s, but we keep the base and we're still adding those 2 exponents. 2 plus 1 is 3. So 4 squared times 4 is 4 to the 3rd. And then letter D, our bases are the same. So 2 is part of our answer. And we're going to add those exponents, 3 plus 2, and we get 5. And that is the answer. All right, now if you don't have, at least one of your numbers don't have a exponent, or look at this. Basically, do you see that 2 and 3 are both the coefficients of a base of y? So when you have coefficients like 2 and 3, you are going to multiply those two numbers together, okay? So 2 times 3 is 6. And now y, we have the same base of y raised to exponents. So now we're going to add 2 and 9, and we get 11. So when you have coefficients, you multiply them. All right, let's look at letter B. So sets of parentheses are another way to show multiplication. So we are multiplying the coefficients of -3 times -4. We get +12. Then we have two bases that are the same, x, that's part of our answer. And now we add those exponents. 3 plus 3 is 6. So that is our final answer. Letter C, we're going to multiply our coefficients. -6 times 8 is -48. We have the bases of A. Both of these are raised to the first power. So 1 plus 1 is A squared. And then B, we have 2 plus 3, and we get 5. And that is our final answer. Now, letter D, I put this, I guess, in the wrong. We haven't talked about negative coefficient or negative exponents, but let me go ahead and do that. All right, so anytime you have a negative exponent, so see, this is the exponent of -3. And this will come up in a few minutes, but I guess I'll go ahead and introduce it. I put this problem in the wrong place, but we're going to go with it. All right, so let's say I have 3 to the, well, we'll just go ahead and do this also. All right, so in math, we have patterns, okay? Things in math should make sense. So if we have 3 to the 3rd power, that's basically 3 times 3 times 3, and that's 27. And then when we have 3 squared, that's 3 times 3 is 9. So how much bigger is 27 than 9? It's 3 times bigger, right? Or you could say that 9 is 1/3 of 27. Well, that it should make sense then that 3 to the 1st power should be 1/3 of 9. Well, 3 to the 1st power is 3. Well, 3 is 1/3 of 9. Well, then it would make sense that 3 to the 0 power is 1/3 of 3. Well, what is 1/3 of 3? 1/3 of 3 is 1, right? 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. Well, then we would go to a negative exponent. See, the exponents are decreasing by 1. So it would make sense that through these patterns that 3 to the -1st power should be 1/3 of 1. Well, what is 1/3 of 1? It's 1/3, okay? So this pattern makes sense. To get from one of these numbers to the next, you multiply by 3, multiply by 3, multiply, so on and so forth, right? So basically, this is telling me that when I have a number raised to a negative exponent, basically what's going to happen is we are going to flip, well, that's not true. It looks like we're going to flip it, but if 3 is on the top, in the numerator, in other words, and we raise it to a negative exponent, we're going to throw it down to the denominator, okay? And the opposite is true as well. If I have 1/3 to the -2nd, well, to get rid of that negative symbol, I'm going to flip what's in the denominator up to the numerator. And when I flip it over the line, I'm going to change the sign. Did you guys hear that little rhyme? You flip it over the line, you're going to change the sign. You flip it over that fraction, that division, that line. When you flip it over the line, it changes your negative exponent to a positive exponent. So 1 to 3 to the negative second is actually 3 to the positive second, which is 9. Okay, so I'm telling you all that to tell you this. So this first number is just a negative 3. It doesn't have an exponent, or basically the exponent is negative 1. So this is just a regular number, negative 3. So basically we have negative 3 times, well, right now this 4 is sitting in the numerator. In order to get it in, to get that negative exponent to be a positive exponent, we're going to flip this whole thing to the denominator. So it's going to come down here and be 4 to the positive third, because we went over the line. We're going to change the sign. So what is that? What's negative 3 times 1? Negative 3 times 1 is negative 3 over what's 4 to the third power? What's 4 times 4 times 4? The answer is 64. So letter D is negative 3 over 64. And we'll come back to negative exponents in just a minute. We'll get a little bit more practice. All right, now the next rule we're going to talk about is evaluating the exponent of 0. So guys, remember my pattern I just did? Did you notice that 3 to the 0 power is 1? Because 1 is 1/3 of 3. Well, that's true for any number to the 0 exponent. Any number to the 0 exponent is equal to 1. Even if it's a variable to a 0 exponent is 1, okay? 100 to the 0 power is 1. That's what it equals, all right? So let's look at letter B. X to the 0 power times x to the third power. Well, we could think of this two different ways. We could think of this as just, well, we know this is 1, and 1 times anything is what we're multiplying 1 by, right? The other way we can think of this is we have two numbers that have the same base. They're being multiplied. So the rule is we add their exponents. So what's 0 plus 3? And of course, 0 plus 3 is 3. So either way you think of this problem, you're going to get the same answer, okay? All right, what about letter C? What if I have a negative something to the 0 power? Well, guess what? It's still 1, okay? The only exception is if the negative is outside the parentheses. Because this means just take 5 to the 0 power first, which is 1, and then make it negative, okay? But if you have any number in parentheses to the 0 power, the final answer is 1. So let's look at letter D. We have x to the 0 power minus y to the 0 power. Well, anything to the 0 power is 1. Minus y to the 0 power is also 1. And 1 minus 1 is 0. That would be our final answer. All right, let's look at the next problems. Now we're going to talk about when we have a division problem. So we're using the quotient rule. The quotient rule is when two numbers have the same base, when two numbers have the same base, and are being divided, the rule is to subtract the exponents. Okay, when two numbers have the same base and are being divided, the rule is subtract the exponents. So what's the exponent of x on the bottom? It's 1. And what's 6 minus 1? The answer is 5. Now, why does that work? So let's say we have 6 x's. This is the same thing as x to the 6th power. 1, 2, 3, 4, 5, 6. And we only have 1 x on the bottom, right? Well, don't you agree that if 5 divided by 5 equals 1, don't you agree that x divided by x it also equals 1? Well, here we have a pair of x's. X divided by x is 1. Well, what do we have left? If these are gone, we have 1, 2, 3, 4, 5 x's left. So that's why subtracting the exponents work. All right, what about 2x's divided by 2x's? Well, x divided by x is 1, x divided by x is 1. So what's the answer? 1, not 0. It's not 0, it's 1, right? The other rule is you would subtract the exponents. So if I have x to the second 2 minus 2 equals 0. Well, if I have x to the 0 power, any number to the 0 power is equal to what? It's equal to 1. That's our final answer. All right, letter C, we have 8 y's on the top, 2 on the bottom. We would get to cancel out 2 pairs. And so what would be left? We'd have 6 y's left on the top. Or in other words, 8 minus 2 is 6. All right, let's look at these. Now we have some coefficients here. 15 and 3 are coefficients, and we can divide 15 and 3 both by 3. So 15 divided by 3 is 5. 3 divided by 3 is 1. Then, so that's just 5. 5 over 1 is equal to 5. And then I'd have 15 x's on the top, 3 on the bottom. I'd have 3 pairs that cancel. So 15 minus 3 is 12, right? All right, what about the next one? What's 20 divided by 2? 20 divided by 2 is 10. 10 minus 2 is 8. And 6 minus 3 is 3. And that's our final answer. These are kind of fun, right? Make sure you look at your guided notebook, page 98. I want you guys to try example 6 and letter A. Try both of those, and we're going to talk about those in class later. All right, so we're going to combine the rules for exponents. And I'm glad I talked about negative exponents separately because we didn't have a negative exponent section, which I should have had, but I don't see one. So let's just do some more examples of those. So let's talk about negative exponents. So let's say I have x to the negative third, and I want you to simplify it with a positive exponent. Well, think of x over 1, right? Well, then you think, okay, well, how do you make that negative exponent a positive? You gotta flip it over the line to change the sign. As soon as you flip it over that line, it becomes a positive exponent. Well, you can't have a blank on the top, so you must have a 1 there. So what if I have x to the negative third over 4? Or yeah, that's fine. All right, so my 4 is just a 4 and it's in the denominator, so it stays exactly where it is. Okay, we don't change anything about the 4, it's just a 4 in the denominator, so it's actually a 4th. But I have a negative exponent. When I simplify, I have to end up with only positive exponents. So I'm going to take this whole thing, put it over the line to change that sign. It'd come down here with a 4. Well, if I don't have anything on the top, I must put a 1 there. Can't leave a blank. And that's even true with the rules, which we'll look at it in just a second. Well, let's go ahead. We'll get into those now. Let's look at those. All right, so letter A, we do have a negative exponent, and here we have a positive 8, right? So let's think about the rule. These are 2 numbers that have the same base. They're both raised to exponents. They're being multiplied, so let's think about the rule. When you have 2 numbers that have the same base, you're going to add the exponents. So the exponents are negative 5, we're going to add it to 8, and we get what? Positive 3. So 2 to the positive third. And 2 times 2 times 2 is equal to 8. That's our final answer, because you can't, even though you can't give a final answer if you have a variable, you know what 2 to the third power is. Now, a different way of looking at this is thinking, okay, well, 2 to the negative 5th, I want a positive exponent. So I'm going to take 2 to the negative 5th, I'm going to flip it to the denominator, and I'm going to write 2 to the positive 5th in the denominator, and it's being multiplied by 2, a whole number 2, so whole numbers always go in the numerator. And now look what's happening, that we just turned that into a division problem, didn't we? Well, the rule for dividing two numbers that have the same base is to subtract their exponents. So isn't 8 minus 5 also 3? So basically our answer would be 2 to the third, which is what we got up here. And 2 to the third is still 8. So 2 different ways of looking at it, and we get the same answer. 2 different ways of looking at it. All right, let's look at letter B. So I have 2 negative exponents. The only way to get rid of negative exponents is to flip them over the lines. I'm going to flip this down here, 10 to the positive 5th. I'm going to flip this one up across the line to change the sign, and I get this. Well, now if I subtracted the exponents, I'm going to get 2 to the negative third, or I can think about it this way. I have 10 times 10 on the top. I have 10 times 10 times 10 times 10 times 10 on the bottom, right? 1, 2, 3, 4, 5. So that pair of 10s would cancel. I'd get 1. That pair of 10s would cancel. And then now what do I have left? I have nothing in the numerator. In the denominator, I have 10 to the third, right? 1, 2, 3. Can't leave the numerator blank. So my answer is 1 over 10 to the third, which is the same as 1/1000th. 1/1000th. And by the way, guys, you can type this in your calculator using your exponent button, using your negative signs, and it should go from this math problem to this answer. Also, letter A, you can type this in your calculator exactly like you see it, and probably most of your calculators will immediately say 8. All right. However, letter C, you can't put that in your calculator. So you do need to know these rules. The calculator definitely helps us. It makes us feel like, oh, I can do that. I got the right answer. But knowing the rules is important because you can't put exponents in your calculator. So what are we going to do here? We got 2 choices. We either think of this as a quotient where we're subtracting our exponents. We got to be careful because it's 6 minus -1, right? And then we do bam, bam, and we get 7. So this is x to the 7th. We could think of it that way. Or we could think, oh, wait, hold on. I have a negative exponent. To make this a positive exponent, I'm going to put it up here with the 6. There it is, +1. And now I have 2 numbers that's being multiplied that have the same base. So 6 plus 1 is 7. So either way you think about it, we get the same answer. All right, letter D. We have 6 x's on the top, 2 on the bottom. 1, 2, 3, 4, 5, 6 over 2. So we cancel out a pair. So the difference in 6 and 2 is 4, and you can think of it as where were the most x's? Well, the most x's were on top, so I have x's left on the top, right? Don't I have 4 x's? And then we have 3 y's on the top and 5 y's on the bottom. So 3 pairs get canceled. Well, the difference in 3 and 5 is 2, and then where would those y's end up being? Well, there's more y's in the denominator, so our final y goes in the denominator. You guys see what I'm saying? Because we could say 3 minus 5 is -2. That just simply means we're going to have y's left in the denominator, not the numerator. And when you put it in the denominator, you don't have to put that negative sign because 3 minus 5 is -2, but we'd have to throw it in the denominator. So if we think about it this way, we automatically know where our variable goes. All right, how about this one? 15 divided by 3 is 5, which is the whole number 5 in the numerator. Now we have these 2 x's on the top, which are being multiplied, right? So 10 plus 2 is 12. We're going to multiply 5 times 2. And then we have x to the 15 on the bottom. All right, so now what do we do? What's 2 times 5? 10. Then guys, look, we have 12 x's in the numerator, 15 in the denominator. So what's the difference in these two numbers? The difference is 3. So where do those 3 x's end up, on the top or bottom? Well, we have more in the denominator, so those 3 extra x's that don't get canceled out stay in the denominator, right? Because 12 minus 15 would be -3, which makes it jump down to the denominator. So this is our final answer. All right, that's the whole first section. Good grief, you guys. That was a lot, wasn't it? Here we go, 7R2. Make sure you go to your guided notebook and you look at pages 101 and 102. There you'll find a summary of power rules for exponents. So basically we have a power raised to a power. So this first one, we have x squared to the 4th power. So basically it's x squared multiplied together 4 times, right? That's technically what this means. So if we add all of these 2's together, we'd have 2, 4, 6, 8. So the rule is if you have a power raised to a power, you're going to multiply those exponents. Multiply the exponents. Power raised to a power. Well, here we have x to the 5th raised to the -2nd. Well, what's 5 times -2? It'd be -10. That is not simplified. You can't have a negative in the exponent and call it simplified. So how do we get rid of a negative exponent? We flip it down to the denominator. And our final answer is 1/x to the 10th. All right, here we're going to multiply power times power. We get y to the -14th. Well, right now that's sitting over 1. The only way to make this a +14 is to flip it in the denominator. It becomes positive. You can't have a blank in the numerator, so the answer is 1/y to the 14th. And then letter D, our base is 2. 3 times -2 is -6. Right now that's sitting in the numerator. So to simplify it, we jump that down, drop it down to the denominator, 2 to the 6th power. And then what is 2 to the 6th power? I have no idea. I'm going to use my calculator. 2 raised to the 6th power is 64. So you guys pause for a second. Go ahead and put this whole problem, the original problem, in your calculator like you see it. 2 to the 3rd power, parentheses, raised to the -2nd. And let's see what your calculator tells you. Mine tells me 1/64. So I went straight from this to this. But like I said, we also have to know the exponent rules because of problems like this. But when our bases are digits, that helps a lot. Now look at these. Sometimes people think, oh, well, it's only x raised to the 2nd power. But guys, remember, every single individual number and or variable is raised to the power of 1, right? So we're going to multiply every single exponent by 2. So 1 times 1 is 2. And once again, 1 times, did I say 1 times 1 is 2? I think I did. 1 times 2 is 2. And then we do it again. 1 times 2 is 2. And then I can simplify 5 squared. We know that 5 squared is 25x squared. And that is our final answer. All right, once again, both of these have exponents of 1. So our final answer is x to the 3rd, y to the 3rd. Don't miss this because you skipped this first exponent of 1. You got to put it there. If you don't see 1, write a 1. All right, let's look at letter C. Now this is technically -7 squared, right? A squared, B squared, because everything has a 1, 1, and 1. What is -7 times -7? 49, positive 49, A squared, B squared. That is the final answer. The more you do, the easier it gets. All right, now on this one, We have ones and ones. So 1 times 5 is negative. 1 times negative 5 is negative 5. Once again, and then guess what? We can't leave those negative exponents. So we got to flip it over the line and change the sign. All right, that's it. That's the final answer. Letter E, everything gets raised to the power of 4. So 2 times 4 is 8. Negative 3 times 4 is negative 12. So you can write it like this, or you can just go, if you know you have a negative exponent, go ahead and throw it down to the bottom and go, okay, well, negative 3 times 4 is negative 12. So I know my y goes in the denominator. Go from here to here as you get more comfortable. All right, now letter F. Some people think, oh, I got to multiply. 5 times negative 6 is negative 30. That's true. But when you do, please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. Parentheses first. Well, there's nothing we do in the parentheses. So guess what comes before multiplication? Exponents. So this needs to be taken care of before we multiply anything by 5. So first thing we're going to do is think, what's negative 6 squared? Negative 6 squared is positive 36 times a, and then 4 times 2 is 8 times 5. Well, 36 times 5 is 180. 180 a to the 8th power is the final answer. All right, and then even if you have fractions, everything has an exponent of 1. If you don't see an exponent, every single number and variable have an exponent of 1, and you multiply every single individual number and or variable by what's on the outside. So we have y to the 5th, x to the 5th. And guess what? That's it. That's our final answer. B would be 2 to the 4th over a to the 4th. Well, anytime you have a number raised to a power, you can simplify it, or you need to simplify it. So our final answer is 16 over a to the 4th. All right, 3 to the 3rd power is 27 over 3 to the 4th power is 64. No, it's not. 4 times, yeah, it is 64. And that's the final answer. That's it. And then, or can we simplify that? No. All right, and then we have 3 to the 2nd power over 7 squared. What's 7 squared? 49, and we are done. All right, so guys, you can pause the video and see if you can do these, okay? So what is negative 2 to the 3rd power? Negative 2 times negative 2 times negative 2 is negative 8. X to the 3rd over y to the 6th. And that's the final answer. And then we have 3 squared, 9. A to the 4th, b to the 2nd over a to the 6th, b to the 4th. Now, if you got that, good, but you're not done yet, because you have a's in the top and bottom and b's in the top and bottom, right? So 9 obviously stays on the top. So now we want to think, what's the difference in 4 and 6? The difference is 2. Do you have more a's on the top or bottom? The bottom. So that difference of 2 goes on the bottom. Same thing with 2 and 4. Difference of 2 and 4 is 2. Do you have more b's in the top or more b's in the bottom? B's in the bottom. So our final answer is 9 over a squared b squared. All right, make sure you go to your guided notebook at pages 101 and 102. I want everybody to practice example 5 and A. Everybody try that. All right, our last section for tonight is 7R3. We're looking for the nth. We're evaluating the nth root. Look at page 105 at the definitions for your rules of exponents. All right, so I put these in your practice on your practice paper. This is a great chart for you guys to keep and refer back to if you need to. So basically you can write radicals like this, square root of a, you can write it in exponent fraction form. So a to the 1/2 power is the same thing as a square root of a. So basically that denominator of your fraction goes outside the radical. It tells you what root is the second root. And then that top number becomes the exponent of what's under the radical. Okay, so a to the first is a. The square root of a is the square root of a. Can't do anything to that. All right, do you notice this? That exponent of 1 would be in the front here. And this is now the third root, or the cubed root, goes outside. This is now talking about the fourth root. So that 4 goes right there inside that little check mark of the radical. And this is a to the first power. Same thing, the nth power, the nth root of a to the first power. And how do you apply these? So 9 to the 1/2 power is the same thing as the square root of 9, which is equal to 3. 125 raised to the 1/3 is the same thing as the cubed root of 125, which is 5. The cubed root of 125 is 5. And then I gotta shut my door, you guys. My dog keeps coming in and out. He's driving me crazy. Sorry. Okay. So, and then the fourth root of 16 is 2. So let's try some of these. So let's look at letter A. Another way of writing this would be the square root of 49 to the first power, which is 7. All right, what about letter B? 81 goes under the radical, so it wants to know what's the fourth root of 81 to the first power. So I don't know, I'm going to put it in my calculator. If I can find the right button. Oh, I use my other calculator. All right, what about the fourth root of 81? And the answer is 3. Are y'all using this calculator? I know a lot of you are using it. All right, what about the cubed root? So this is asking what is the cubed root of -8 to the first power? Remember, that's a real number, right? It's -2. You can throw that right in your calculator. And then what about the square root of -16? That is not a non-real number, or it's 4i if we were doing imaginary numbers, but Hawks doesn't do. You would just say it's a non-real number. All right, so how would we write this right here? Remember, the denominator of our exponent is the nth root. So this is the third root of x squared. The third root of x squared is how we're going to write that. This one is asking what? Our root is the fifth root of 3x to the fourth. Because remember, this technically has the exponent. 3 has an exponent of 1. And then we have basically a coefficient of -1, right? So only that a is to the power of 3/2. So it's asking what is the square root of -1 times 3a to the cubed, or a cubed. Well, can you have the square root of a negative number? So this is a non-real answer, non-real. All right, now we're going to convert this to the fraction notation, right? So we would say a to the 5/6 because the denominator is that power, or the root, excuse me. All right, what about this one? So this is asking what is the square root of x? So we'd say x to the 1/2, and then 5 would go in front of it, right? Oh, you know what? That makes me realize I wrote this other one wrong. I did. Look what I did. That 3, since that, and I even said it, you guys, that 3 is not raised to a power, is it? So that means the 3 goes outside. Oh my goodness, I just caught my own mistake, you guys. Look at that. That is correct. This is not correct. So don't make the same mistake I just made. I even said it out loud. That 3 does not have an exponent of a 1/2 or 4/5. So please go back and correct that. All right, what about this one? We have a -1, -1 to, it's asking, let's see, -4, and that would be 1/3. Well, that makes me realize that other one was wrong too, you guys. Let's look at how that's written. Let's look at how that's written. That means we would have -1, which is not raised to that power. It's just the A. And then we have the square root of A to the 3rd. So this is how that one should be written. There it is right there. Once again, this is not right. So can you guys correct both of those, please? Yep, let's get rid of these. These are wrong. Got to learn from our mistakes. All right, so now does that make sense? Especially after we do these two, the way this is written, it has to be this way. And this one has to be this way, which helps me realize what I told you earlier wasn't right. Please forgive me. All right, let's look at this one. So we're going to remember both of those exponents of 1 is going to be multiplied by 2/3. So basically we have 27 to the 2/3 power over 8 to the 2/3 power. Well, how are we going to write this? We would write what is the cubed root of 27 squared over the cubed root of 8 squared. Well, we can keep going, right? The cubed root of 27 squared, what is 27 squared? 27 squared is 729 over the cubed root of 64. Well, I think both of those are perfect cubes. So what is the cubed root of 729? The answer is 9. And the cubed root of 64 is 4. So that's the final answer. This is one of your Hawks. This is one of my Hawks certified questions. So you'll probably have one very similar to that. So the final answer is 9 to the 4th. And guess what? If you put that straight in your calculator, the original problem, I bet you $1 it'll go straight to 9/4. I bet you $1. All right, so let's look at combining all of those exponent rules and these rational exponents together. So we have two numbers that have the same base, and those are we have two numbers that have the same base that are being multiplied. So the rule is to add those exponents. So what is 2/3 plus 1/6? The answer is 5/6. So this would be x raised to the 5/6 power. And if it asked us to go further and convert this, then we would say it's the 6th root of x to the 5th. So these are equivalent, aren't they? All right, what about we have two bases, the same base that are being divided? What is the rule? What do you do with their exponents? The rule is you subtract them. So we have 3/4 minus 1/3, and the answer is 5/12. So x to the 5/12, which is a good answer. If we had to go a step further, we'd say the 12th root of x to the 5th. And then we have a power raised to a power. So first thing we're going to do is multiply this exponent of 1 by 3 and 1/4 times 3. So 2 to the third, which is 8, times a to 1/3 times 4 is 3/4. So we know that 2/3 is 8 times a to the 3/4 power. And if we went any further, we would say this. And those are equivalent. Oh my goodness, look at these. Power to a power. So we're going to say 27 raised to the negative 1/3 power times 9 raised to the, first of all, when you multiply negative times a negative, you get a positive. So positive 9/30. So then let's see what our calculator says. 27 raised, whoops, that's not right. 27 to the negative 1/3 equals 1/3. 1/3, because it would be, oh, I know what's happening here. So it's the cubed root of 27 to the negative first power. Well, remember, anything to the negative first power, you would flip that down to the denominator. So basically, this is asking, what is the cubed root of 1/27? Well, the cubed root of 1 is 1, and the cubed root of 27 is 3. Yep. So all of this is 1/3. So your final answer would be 1/3 y raised to 9/30. Wasn't that crazy? Just make up all kinds of stuff with these things, right? I love it. All right, I'm going to erase this. You got it? All right, let's do the next one. All right, so this is basically the square root. Okay, so this whole thing's in parentheses, which means it has to stay together. Negative 36 to the negative first power, and it's asking what the square root of this is. Well, basically, negative 36 to the negative first would become 1 over negative 36, which is a non-perfect square. So just to be sure, I'm going to put it in my calculator. I'm going to put parentheses negative 36 raised to the, and I'm going to do fraction negative 1/2, and it says error, because even if it's a fraction, if it's a negative fraction, you can't have the square root of a negative number, period. So it's a non-real number. All right. And then letter F. So everything's raised to the 1/2 power. So I have 49. So that 1 times 1/2 is 1/2. X, so 6 times 1/2 is 3. And then y, so negative 2/1 times 1/2 is negative 1 over z, so negative 4 times 1/2 is negative 2. All right, now what can we do? Let's take care of the 49 to the 1/2 power is basically the square root of 49, which is 7. Nothing happens to our x, it's just x to the third, beautiful. This y to the negative first has a flip down to the denominator, so that 1 becomes positive, and that z to the negative second jumps up to the numerator, so our 2 becomes positive exponent, and there is our answer simplified. All right. I'm just gonna double, triple, double, quadruple check. Where's my pen? Oh, I'm writing on the wrong thing. I'm gonna throw this in my calculator. in my calculator, I'm putting negative, and then I'm doing a cubed root to the 4th power equals, and I got negative. Oh, I should have put this in my calculator maybe. All right, let me put this in my calculator. I'm going to put -4 to the, I'm going to see if these two numbers match. 1/3, and they're exactly the same number. Yep. So when I put this in my calculator and this in my calculator, it helped confirm in my brain that this is right because they're identical in my calculator. So good thing for calculators, always can reassure us that we're doing it right. All right, so make sure you take a look at your guided notebook, page 405. I want you guys to practice number 4 and letter A. Oh, and this is just this last sheet here just confirms how we are going to do this problem, right? So you guys have been doing so well with your calculators. I'm pretty sure you guys know exactly how to type this in. So basically 125 raised to the 4/3 power is 625. Because it would be, what is the cubed root of 125 to the 4th power? 125 to the 4th power is a huge number. And then the cubed root of that number is, guess what, 625. So you guys, the last question is, what is 36 raised to the 3/5 power? I'm putting in my calculator. What'd you guys get? I got 8.58. Is that right? 8.58. Basically, we're finding what is the 5th root of 36 to the 3rd power. Well, 36 raised to the 3rd power is 4, 6, 6, 5, 6. And we find the 5th root of that. Nope, 5. Whoops, I messed up. 5. That number, and I get the same number, 8.585814487. All right, you guys, well, make sure you're working on your exploration project, your little paper. And then for my Monday night class, I've had a death in the family, unfortunately. We lost our my grandmother this weekend, and so Monday night is the funeral. So I won't be live with you guys in class for Monday night only. But make sure if you have any questions at all, go to the tutoring lab and they'll help you out. And of course, also your college algebra teacher will be able to answer your questions as well. All right, you guys, I hope you have a great day and I will see you for class Tuesday or Wednesday night. All right, y'all have a good week. I'll see you later.